All right, let's do some work with parallel lines and angle bisectors when we have some ratios. So first figure you're kind of familiar with already, except for this is just going to take it a little bit further with being able to recognize different ratios. So you can do top over bottom, you can do top over the whole thing, or you can do the bottom over the whole thing. As long as the left and right ratios correspond, it's going to work out. Same with this guy here. You can do top over bottom, top over the whole thing, and bottom over the whole thing. And yes, you are allowed to flip. So you could do the whole thing over the bottom, whole thing over the top, or bottom over the top. It doesn't matter. As long as the ratio on the left and right have the exact same place, it'll work. With an angle bisector, it's going to split this piece. So A is actually over B and X is over Y. But in the event that you have this entire side, you can add B and Y and A and X. Okay, so those are the ratios that are going to exist in these problems. So basically, this is just this is just extra practice with setting up a similar ratio for both the left and right side of your proportion. So for this guy, we have a top and a bottom, and we have a top and a bottom. So this one is just as simple as it gets. You're just going to say 3 over 5 is equal to 6 over x. Top over bottom is equal to top over bottom. So that's just going to cross multiply and give you 3x is equal to 30. So for this guy, we know x is equal to 10. Okay? Now in the next one, there are two different ways you can do this problem. You can do top over bottom is equal to top over bottom, or you can do top over the whole thing is equal to the top over the whole thing for the left side and the right side. And that's because we know this is x, we know this is 8, we know this is also x plus 8. It's the sum of the top and the bottom. This is 3 and this is 9, but because they're just numbers, we can easily just subtract 3 from 9 and say that this bottom piece is going to be 6. So the easiest way to do this problem would just be x over 8 is equal to 3 over 6, which is top over bottom is equal to top over bottom. That eliminates the need of two variables. So that's just going to give you 6x is equal to 24, so x is equal to 4. And that's it. You're done. Now this next one, you have two different ways you can do it. We have top and bottom. We have top and we could say this is x minus 3. Or we can add those two together and say that this is 10. So the easier way to do this, so you don't have to use, a binomial instead, would just be top over the whole thing. So that would be 3 over x is equal to 2 over 10. Okay, then you get your 2x is equal to 30, so x is equal to 15, and you're good to go. All right, so that's some practice with the little triangle and the big triangle where you're only using the left and right sides. Here is some angle bisector stuff. So we have 3 over 9 is equal to x over 12. So 36 is equal to 9x, so we know that x is equal to 4. Now, I've done a few problems for you. Why don't you take a couple of tries and try the next two on your own. Go ahead and pause the video and press play when you're ready to see how it goes. So this guy, you should have had 6 over x is equal to 8 over 2x minus 2, giving you 12x minus 12 is equal to 8x. So that's going to give you a negative 12 is equal to a negative 4x, so x is equal to 3. And for the last one, you're going to have 2x over 10 is equal to 6x plus 4 over 20. And that means 40x is equal to 60x plus 40. Negative 20x is equal to 40, which means x is equal to a negative 2. Now, think about that for a second. Can x equal a negative 2? Nope, because you can't have a negative 4 or a negative 8 for lengths of a side. So this one actually has no solution. Okay? Once you solve for x, that does not mean you're done. You have to make sure that it actually works in the problem. So that's it for angle bisector problems. So let's go ahead and look at railroad track problems is what we'll call these for fun. Again, it's just looking at, can you decide what ratio you're working with? So top over bottom, or top over the whole thing, top over the whole thing, or bottom over the whole thing. So over here you have a bottom and a hole. But it's easy enough to say that we can subtract 8 from 14 and find out that the top is 6. Okay, so we have x over 4 and 6 over 8. That means x is going to be equal to 3. Plain and simple. Now the next one has 3 different stacks, and it has 2 different variables we're looking for. But the ratio still is going to be the same. Not necessarily from top to the middle and middle to the bottom. Those can be different as long as middle, bottom is the same left and right. Or top, middle is the same left and right. So this one you just have to come up with 2 different ratios, one for x, one for y. There are multiple for each. So why don't you see if you can find x and y on your own. Pause it and try. Okay, for x, the easiest way to find x would just be 2 over x, top over middle, is equal to 4 over 10, top over middle. You only want one variable in your proportion, because then you can just cross multiply here and say that 4x is equal to 20, so x is equal to 5. And then to find y, it's really simple. Now that you know that x is 5, you can put a 5 in here and use that. But if you wanted to find y independently without having to rely on 5, you can do top over bottom. 2 over 3 is equal to top over bottom, 4 over y, without having to rely on the 5. You can go from here all the way down to here because those exact same ratios are going to be true on the left and right. So then you get your 2y is equal to 12, so y is equal to 6. Okay, and then if you want to make sure that you're doing everything correctly, you can check all of your answers. So you know 2 over 4 reduces to 1/2. You know 5 over 10 reduces to 1/2. And now you also know that 3 over 6 reduces to 1/2. So look, the left and right all have the exact same ratios. So that's a way you can check when you're done. Okay, so these last 2 are just a little bit of a challenge. They're not too crazy difficult, but why don't you go ahead and give it a try and see if you can get both of these correct. Just pause it and press play when you're ready. Okay, so you have to find something that works where you only have one variable. So for x, there's 2 different choices that I see. You could do x over 2 and 2 over 4. Or you can do x over 3 and 4 over 12. It does not matter. Okay, so I'm just going to go x over 2 is equal to 2 over 4. So you should have x is equal to 1, no matter what you do. To find y, you can use 1, but remember, if you find x incorrectly, then that means y is going to be wrong even if you set it up correctly. So for y, what I would do is I would go with 2 over y is equal to 4 over 12, and that's going to give us the same thing. Cross multiply, and y is going to be equal to 6, and from there we just have to find z. So yes, you can use 6 if you want to. Otherwise, to find z independently without having to worry about x or y, you can just use middle over bottom and middle over bottom. So 3 over 2 is equal to 12 over z. So 3z is equal to 24. So z is equal to 8. And there you go. So you have just found all 3. So if you have that correct, and even if you did it in a different way and you got the same answers, you are good to go. You are allowed to do it as long as you have the exact same ratios, you're fine. Okay? And last for this guy, this is going to give us x plus 4, because if you add the top and the bottom, we have x plus 2, which is going to give us x plus 4. So for this, what I would do would be 2 over x plus 4 is equal to x over 16. And then you cross multiply, you get x squared plus 4x is equal to 32. So x squared plus 4x minus 32 is equal to 0, which is going to give you your x plus 8 and x minus 4, which means x is equal to 4 and negative 8. Of course, you have to check and see if negative 8 works. You cannot have a negative 8 for that length right there. You cannot have a negative 6 for that length there, so the negative x or the negative 8 does not work. Only the 4. And that's it for this lesson. So again, when you're writing ratios and proportions, just make sure your ratio is the same. Top over middle, top over middle, top over the whole, top over the whole. Left over right is equal to whatever. As long as you keep the ratios the same, you're going to be good to go. All right? This is Longo, and I'm out. See you, bye.